What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovy, and in this series we're building your game. Now, what I wanted to get to in this episode was to add another enemy type. I think back in the day, there was somebody who asked, why not both in terms of shooting or chasing the player? And I myself was thinking of some interesting, a little bit funky behaviors that we could have where maybe when the enemy is seeing the player with the human side, they're shooting. And then when the player loses the human, then actually what they do is that they do something different in that case. They actually slow the player down, for example. So I've prepared this weird crab insect like guy, kind of weird. At first he looked too much like a cat, so I made him look more insect-like, and it looks pretty gross, but that's perfect because he's an enemy and we're supposed to kill him. So we're gonna go ahead and add this in. You can find the image linked in the comments description, just underneath somewhere there. And what we're gonna do is that I'm gonna introduce you guys to how to use class inheritance in Lua and make your own custom parent classes. So we have this enemy, but we're gonna want to split the functionality into two different types of enemies so that we can actually generalize the enemy behavior into one enemy class, which will be the parent class, and then we can have a more customized enemy, which would be the different children from that enemy class. So we're gonna keep this enemy file as is. I'm just gonna create another enemy called enemy. I don't want to call it enemy 1. It's kind of dumb. I mean, I named the file enemy 2, so it implies enemy 1, but let's find a better name. Jellyfish.lua. All right, we're gonna name it after sea creatures now. So we're gonna name it jellyfish.lua, and we're gonna create a crab.lua. Yoo-hoo! We're going ocean theme. And so this jellyfish is actually we're gonna create the class right here. So first of all, everybody, you know the drill. Give me a GFX, cons, playdate, graphics, yahoo! And then we're gonna actually create a jellyfish class. So we're gonna do it the nice way. So it's gonna be -- at class. And then jellyfish, we're not going to do jellyfish, we're just going to, with a capital F, we're going to keep the F lowercase, :playdate.graphics.sprite. And then we're going to do jellyfish equals empty table, and then we're going to do class open brackets, in quotes, jellyfish, and then after the brackets, dot extends open brackets gfx.sprite. Yee! Perfect. So now we have our jellyfish class. Oh, you know what? This is the lesson, guys. So actually by doing this, what we're doing is that we're extending the playdate.graphics.sprite class, and we're using it as a parent class. So if you'll remember, if we do function jellyfish : init open close brackets, then we add an end, and then I do jellyfish.super.init, and I pass in the self. What that does is that it actually calls the parent class, the super class, and it calls the initializer of that super class, which is kind of important to do in stuff like init functions, because or else we don't run any of the playdate.graphics.sprite functionality. So all of this is still going to apply when we're adding our own custom parent class. So we're going to go ahead and, you know what, I'm going to copy and paste all of that. I'm going to go into the crab.lua, I'm going to paste it there, and I'm just going to do F2 on jellyfish and replace it with crab with a capital C. And replace it, and you can see that it didn't catch it everywhere because here we have it in quotes, here we have it in the documentation. So I'm just going to replace everything with crab, and basically we've just created two new sprites that have for now no functionality at all, but I'm going to make sure to include them in my sprites.lua. So I'm going to do import sprites / crab and import sprites / jellyfish. Okay, so that's going to import all my new sprites. So in theory, we can run the game. There's no, what's the error? Sorry guys, I named this file wrong. I think it should be width and then height. You guys won't have that problem. The file will be properly named. Okay, so I can still run it and the enemies are spawning as usual. So now, instead of the enemy class, I'm actually gonna replace the enemy class with the jellyfish class. So we're gonna go into the main.lua. We're gonna have this spawner functionality here, and instead of spawner, I'm gonna pass in jellyfish, and I'm gonna say jellyfish.spawnRate per tick. So what's the mystery there, guys? That's not gonna work if we run it right now, right? If you want, you can try it. Trust me, it won't work. This is what we're gonna do. We're gonna do class jellyfish. So inside jellyfish.lua, we're gonna do class jellyfish extends, and in here, we're actually gonna say enemy instead of PlayDate.graphics.sprite. And I'm gonna even replace it up here in the documentation as well, even if he doesn't recognize enemy. Why is that? It's because we haven't defined it in the documentation here. So we're gonna add 3 dashes, class enemy equals playdate.graphics.sprite. And then we're gonna do enemy equals empty brackets, and then the initializer as it was before. So now it shouldn't complain anymore. However, I'm getting a duplicate field, probably because I'm reinitializing the init from the enemy class, I guess.
A few moments later.
Sorry guys, we're gonna have to deal with this duplicate field thing for now, unless you really want to get rid of it, but we're gonna ignore it for now. So here we're calling the super init, as you can see. We're actually doing this from the crab function. Oh, wait a minute. That's funny. So when I did F2, that actually replaced it in both files, not just the jellyfish one. So apologies. I need to go ahead and put jellyfish back in there. So in theory, now we can actually run this and it should keep the game running as normal, because the jellyfish class is actually going to be calling the enemy class for all of its functionality. Let's run it and see if it works. And you can see that it works. So how does this work is a question. So let's add, for example, function jellyfish dot colon update. All right. So first of all, if we don't put anything here and we run the game, you can see that nothing moves. Jellyfish is frozen. He's not changing his behavior or anything like that. If I add jellyfish dot super dot update self, and I run it, you can see that it's acting normally. So how come when I delete everything, nothing, like it runs normally? So if I add a breakpoint here, what you can see is that this, and I'm gonna add a breakpoint so the code is stopping on this line, and I hit go into, you can see that it's going into enemy colon update like that. And over here you have the call stack. So you can see main.lua is calling sprite.update. It's gonna run some C code, and then it's gonna go into jellyfish, and then it's gonna go into enemy.update. Now, what happens if I remove jellyfish colon update altogether and I rerun it? Then you can see that things are running as we saw before. If I hit a breakpoint on enemy colon update, you're gonna see that actually the enemy colon update is being called directly from the SDK. And that's because the SDK knows that my jellyfish is an enemy. And so it's calling enemy.update for that reason. Same thing goes when I say, like, for example, enemy colon add. I don't know if I have that somewhere. Player, particles, anyways, it works for any sprite. What's happening is that it calls the class, and Lua first checks whether that class has an add function. And if there's no add function, then it's gonna actually go look at the super class, the parent class, and see whether that has an add function. And so because add has been defined by the SDK, and same with the update function. Both of those are called by the system without any issue, basically. Meanwhile, if you add it, then you got to make sure to also call the parent one, super one, or else it's not going to get called at all. So I don't know if I've explained that before, but anyways, I just wanted to let you know, just to be extra clear. So if we want to add any functionality to the child class, we got to make sure to call the parent there. And so in this case, we're going to actually take most of the functionality out of enemy because we don't need it to be that specific, and we're going to put it inside jellyfish. So I will go ahead and guide you guys so that you can do that with me. I'm going to pause the simulator, just stop it right there. So these constants and the image table, first of all, we can take those and put those underneath the enemy class here. Sorry, I'm going to put them above the enemy class. Then I'm going to go ahead and, so we have the enemy spawn rate per tick. We're going to actually make that into the jellyfish spawn rate per tick. Don't touch the class definition in enemy, because without that we're going to have a problem. So we're going to change this to jellyfish dot spawn rate per tick, and we actually have to put that below the definition of the class, or else it's not going to exist at that point in time. Then we've got image table, set collide rect, and then animation loop. So in theory, we need to take this image table with us. We're going to add an image parameter, keep it simple. So the PlayDate.graphics.sprite initializer takes in an image as a second parameter after the self. So I'm going to go ahead and retrieve that image and pass it down. I'm going to leave the collide rect there because when you set the image, it also sets the size, and here we're setting the collide rect to its own size, which is fine. In the jellyfish, inside the super.init call, I'm actually going to pass in image table enemy in brackets 1, the thing that we just took away, and I'm going to take this create animation loop as well and put it at the bottom of the jellyfish init. So we're just leaving one line extra inside the parent class, which is the set collide rect, and that will be called for every instance of end. For now, we like it that way. We don't need to change it. We can leave it. Then enemy destroy score.update 50. So in this case, what we can do is that we can actually set a score value on our class. So we're going to do enemy.score kill equals 50. And then what we do is that we score.update. So we're going to say local score kill equals, and then we have to get our own class and get that score value, which I am now asking myself, how do we get our own class? So we're going to do get score value. We're going to add a function. It's going to be function enemy colon get score value, and then we're going to do return enemy dot score kill. So we're going to do right there get self colon get score value score kill, and then we're going to do score dot update score kill. So we don't need to override the destroy function. However, we will override the get score value function. So let's do that right now. We're going to do function jellyfish colon get score value, and instead of returning 50, well, actually here we can actually return 50 because that was our initial score. I'm gonna go ahead and change this to 40 just to change it up a little bit. So we have a default score kill value here, which, you know, maybe we can set to 0. I don't know. In theory, we can also override the class score kill, but because we're not using that down the line, I'm not doing things perfectly. Anyways, it works. Let's keep it this way. Then we've got the enemy update. And so this is actually the very specific movement of the jellyfish. So we're just going to copy and paste the entire block of code here in the enemy. And we're going to go put it inside the jellyfish function jellyfish colon update. Oh, sorry. I recreated the function, but we don't need to because we've already recreated it. But just for cleanliness, I'm going to move this down. I'm going to move this update down to the bottom. And I'm going to remove, double check this. Jellyfish colon update needs jellyfish super update self. It's the first line. And then the code that we just copied from enemy.lua. which is below. Now, maybe the one thing that we can do, which could be more interesting, is to extract out the player instance so that not every jellyfish has to get it, but instead the enemy has the instance of the player. So what we can do here is we can do player.getInstance. Inside the enemy, I'm gonna do enemy.target equals nil. So I'm just initializing a placeholder there. And then inside update, I'm actually going to go get the player instance, and I'm going to say enemy.target equals player. Now, here's the thing, is that this is actually going to get called for every enemy, and we don't need to do that. We only need just one enemy call to do this. So what we can do, I'm complicating things a little bit. You don't have to do all of this, but it's just going to be a small efficiency win. So we're going to say local frame last target refresh. Okay. So that's basically going to set the current time, or time last target refresh, let's name it. So if we say if not time last target refresh, or time last target refresh is less than playdate.getTime, current time in milliseconds. I don't know what the difference is between get time and get current time in milliseconds. You can look up the docs. And then we're going to do it right here. Local player equals player.getInstance, enemy.target equals player, and last target refresh equals playdate.getCurrent time in milliseconds. There we go. Okay, so this is going to refresh the player instance once per class. Honestly, it's not a huge win, guys, because of the fact that we're actually checking multiple things in the if statement, and player.getInstance is basically the same amount of complexity. In fact, we might even add more. However, what it does help with is a little bit of cleanliness, because we can say if self.target. And so what we can also do here is if player : has died, open close brackets. Oh, sorry, if not player, open close, has died, then enemy.target equals player, else enemy.target equals nil, end. So you see what we're doing is that we're generalizing the target of the enemy so that we can also point it towards other things. And who knows, that might come in useful. So I'm actually going to do one more thing. I'm also going to create function enemy : get target, and then return enemy.target here. So this will allow us to override child functionality, so that we are returning a different target for the children. So, okay. And in theory, we can actually make these locals. So we don't need to do enemy.scoreKill anymore. We can do local score kill and local target. And instead of enemy.target, we're just going to do score kill, target equals player, target equals nil. This is a local one, and we're using the function, so we can leave it there. So it's just the get score value and the get target that are worth replacing. Okay, and then we have to go ahead and do if. So here, get the player, I'm going to do local target. So I'm going to say get the target instead of get the player, equals self : get target. And then if target, then, and then we just have to replace the target X, target Y, X player. Oh, I mean, the naming is... This is always annoying, the X and Y namings when you've got calculations. So let's say X target, even if I'm going to change it in a second, Y target. So Y target minus self.y, X target. And then we're going to do, instead of X target and Y target for the second one, I'm going to do X final and then Y final. I know it's not amazing, but, and we're going to replace it on the geopoint new for the animator movement. So X final, Y final. All right, I hope you guys stuck along for that one. Let's rerun the game and see whether any of this works. Haha, it didn't work. So the line is in enemy.lua inside the update function. It's if player and not player colon get has died. Okay, perfect. Rerun. And still broken. Let's see what's up. Yes, we forgot to copy over geo. In fact, we don't even need it in the enemy parent class anymore. So jellyfish, local geo. All right, rerun. And you can see that our guides are working as normally. However, they're flying through the player. We're not having any issues anymore. Or like we're not having we're not colliding into the enemies anymore. So let's quickly fix this. That's gonna be player, and then I'm gonna go ahead and say, because it's gonna be asking whether it's an enemy or not. So let's just type in search enemy. Okay, there it is. So player colon update, move and collisions. And then we're gonna do inside the for loop of collisions, there's if not self.timer loss, collision.other.class equals enemy. So we're gonna do, so I mean we could check the super class, but that's a bit of an extra piece of work to do. So for now I'm just gonna do jellyfish because that's our only enemy class. And we're gonna, so now the game works again. Boom, there we go. All right, as you can see, game works as it's supposed to. So we're going to do the full implementation of the second class, which will require some extra modification. And until then, I will see you guys in the next one. Bye-bye.